we are welcome to this platform this morning, this afternoon, this evening, no matter whatever you are on the planet.
Thank you, sir.
So you will pick any of the greeting that pertains to your own. Anyway, we move on to, I'll quickly share my screen. Then from there, we proceed to our activities for today. So we stopped last week on the, let me try and see. Where I got those area. So we'll be talking about Cauchy-Euler method of differential equation. That's why we'll be taking them one after the other. Those things that we'll be discussing here and there. So from there, we will also analyze some of those key things that are responsible for solving ODE in this context. Probably towards the end of the class or the end of the semester, when your timetable is not out yet, right?
No, it's not out. It's not out yet.
Okay, so all these things we've discussed earlier on will still be what we'll be using to solve some of those problems, but I will not come back to this one. The next topic we are doing, I will do homogeneous and non-homogeneous of the Cauchy-Euler method, differential equation. We'll also be talking about particular and the complementary solution, whereby we had the two together and it's become, look at this application that we did some times ago. All those things are key to the success in this case. So what I will just advise you is recognize the differential equation. How do they write it? Look at this exact solution that we did here. How do we write it? When do we, we first of all discuss about the method, and now we are using them to apply to solve some of the problems we are facing in this case. You remember this when we are solving, these are the things we'll be using all through when we are talking about this linear differential equation method. We have, when you have your lead constant, the form of y particular for constant is there. Where you have the linear, where you have the quadratic polynomial, when you have the cubic, and so on. These are the things we'll be using. I want you guys to continue to do the revision so that when you get to the exam, you won't meet the surprise in the all. And you know that, yes, you have it. You see, it is better you do the revision and master those methods. Do it as if tomorrow is your next exam. Don't wait till the final day, please. I'm begging you. People that are not here, don't let them be better than you, that you are here. So it's going to be a double dose for you. When some people are not here and they still pass, and you that you are attending, you are not doing the needful, you're in trouble then. Let's try as much as possible to do the constant practice. Okay, let's look at this. We have Cauchy and Euler. second differential second order differential equation. So it's just going to be a kind of summary. I don't like wasting time and giving you stories you need to write. If you want the story, please visit your books. So in this form, how does it look like? The form of this, we have ax squared y prime prime plus bs y prime plus cy equals to g of x. So when you have this, at what point do we say it's homogeneous? At what point do we say it's not homogeneous? Now, it is homogeneous when you have, it is homogeneous when g of s is equals to 0. And it is non-homogeneous when g of x is not equals to 0. That's just it. That's the difference between the two. They are of the same form, but it is homogeneous when the g of s is equals to 0. But when it's not equals to 0, it is not homogeneous. So what are the things we need to take notes in this case? There are several things we need to take notes in this context. One of it is we find our, what we call our M, we'll represent them, and then from then we'll be able to solve some of the problems. So let's first of all look the way, how do we solve the equation that we declare above? How do we solve them? So that's the first step. Then after solving them, we can now look at it in another dimension. What is the final result in this case? We solve it using homogeneous, and we solve it when we have non-homogeneous. So let's start. For this, we find one of the method is to find a solution of the form y equals to s raised to power m. Your y can be raised to power n, can be s raised to power r, or anything. But I choose to just use y equals to s raised to power m. So if my y is equals to s raised to power m, so what is my y prime? Anybody? Who can tell us the y prime in this case? Remember, you have the equation 1. Let's call this one equation 1 here. Our equation 1 is y prime prime, y prime, and y. So we need to define the y. We already have assumed the y to be s raised to power n. So what is y prime?
Y prime will be mx m minus 1.
Okay, y prime will be what? mx m minus 1. So what about y prime prime? It's going to be m in brackets m minus 1 s raised to power m minus 2. Do we agree?
Yes, sir.
Okay. Now we are going to substitute. Then you now say equation 1 becomes what? You substitute them into your equation 1. We have as squared. As squared. What is y prime prime? M into m minus 1 s raised to power m minus 2. Close the bracket. plus bs of y prime, ms. Are you getting it now?
Yes, sir.
Is it only Ibrahim do we have on the platform? Others, are we still there?
Yes, sir. Yes, sir.
Okay. So we are substituting into it plus c. We know c is s raised to cy is this equals to 0. We are solving homogeneous because it's easier to prove the homogeneous now. So that let's move on. So the next thing we need to do is something is common to them. What is common? Somebody should tell me. Who can tell me? Okay, let me do it one by one. Look at this. I can bring Sm out. S raised to power m minus 2 out. I have a S2 and Sm minus 2 in brackets m into, let me use big brackets, plus bs dot Sm minus 1 in brackets what m plus c in brackets Sm equals to 0. Now, you agree with me that anytime you have a raised to power n multiplied by a raised to power m is the same thing as a raised to power, yes, Olatunji? You are raising up your hand, Tolulope. We can't hear you, please, if you are talking. Okay, I hope you understand this now. So let's do this one first. It's the same thing applicable to x raised to power 2 multiplied by s raised to power m minus 2. What do we have is s2 plus m minus 2. So at the end of the day, you have s raised to power m. Are we together?
Yes, sir.
Do we agree?
Yes, sir.
We have a s raised to power m. So in brackets m into m minus 1. Now, the same thing applicable here. Instead of, we have s raised to power 1 here and m minus 1 here. So at the end of the day, 1 plus 1 minus 1, this will still give you bm. We have b s raised to power m into m. Plus c into sm equals to 0. So what is common to them? I can get sm all through, right? I can factorize my sm out. Factorize my sm out, I'm going to have sm. I can take my a inter back to this one, plus bm plus c equals to 0. So at the end of the day, if I open this bracket, what do I have? Sm into am squared minus am plus bm plus c equals to 0. So m is also common there. Sm is a raised to power m squared plus b minus a, m plus c equals to 0.
Excuse me, sir.
Any question?
From that am squared minus am, I think they can cancel now because this was just like am to power 1. We can cancel one of the am. We are left with
No,
am.
you can only cancel when you are doing multiplication, not when you are doing addition or subtraction. Is that okay?
Okay.
You can only cancel when you are doing multiplication, not when you are doing addition or subtraction. I hope that is okay, clear now.
Oh, it's okay.
So in this case now, how do we get our y out? Remember, this is a quadratic form, and we can now say homogeneous form. You remember when we, for homogeneous, homogeneous form, that is talking about distinct real roots. They are distinct real roots of homogeneous. That's what we are trying to do. So at this point, we are going to write our m. When we are looking for m, our m will be y equals to c1 s raised to power m1 plus c2 s raised to power m2. How do you get your real? The distant real. You remember from the, this is your answer anyway. This is where we are going. But let me quickly explain something for you. You remember in the, when you are doing general formula of quadratic, where it's a minus b plus or minus square root of b squared minus 4ac over 2a. Now, how do we do it? Anytime you have b squared minus 4ac greater than 0, what does it mean? Then when b squared minus 4ac less than 0, what does it mean? And when b squared minus 4ac equals to 0, what does it mean? Go and check it by yourself. You will understand that you have distinct roots. You have the one that is not distinct root, the real root. You have 3 of them. So go and check the 3 conditions. That is where this thing come up. So it is for you to do that for your own interest, so that you have idea of how do they normally get it. Don't bother yourself. This, we call this one discriminant factor. This is what they call discriminant factor that we use to do that. So when you are Google it, and you will get your final detail there. So I'm not supposed to come here because
Hello,
this, yes.
This formula you wrote, it looks similar to the one we have when we have C1 e raised to power.
It's the same thing.
Okay.
It's the same thing. It's not similar. It's the same.
Okay.
You remember I gave you initially from the first bit. We prove it then. You remember?
Yeah, I guess
so. It's the same thing. I'm just giving you the genesis of it.
Okay.
It's the same. So now I just digress. That's why I'm trying to explain here. So the major thing is what we did here is, in most cases, you divide through by what? M. S, you divide through by s raised to power m. When you divide through by s raised to power m, you remember when it comes to this place, it comes to 0. That is the meaning. That is, if you said divide through by s raised to power m, which implies that am squared plus b minus am plus c equals to 0. That's all. That's what you remain. So that's what now led to this one. So take note of that. So this particular one, you come up when you solve for this. You have your M1 and M2. As a quadratic, you have M1 and M2. Okay. Yes, Oluwaseun.
Please, I can't see the screen again, sir.
Is your network? Oh, can everybody see the screen?
Yes, sir.
Sheung, move to where you can get the good network. Okay, let's continue. Let's look at the example. Example 1. Example 1. So, number 1 example will be x squared y prime prime plus 7xy prime plus 8y equals to 0. Now, in this case, let's call this one equation 2. This particular one. Equation 2. Can you see the equation 2 now? So, what do you think is represents? What is A in this case? Remember this formula. We will continue to use this formula throughout. So what is A? Who can tell us A? From here.
1,
Thank you. What is B?
7,
And C?
8.
I hope every one of us we are together now. It's as if we are solving quadratic equation. But we want to represent it now. Now that we know that A is 1, we have equation triangle here that says A is 1. Then we have m squared plus, what is B? 7 minus A, 1. M plus 8 equals to 0. Any question? Any question? Silence means no question. Okay. M squared plus 6m plus 8 equals to 0. Right? So can you tell me, how do we break this one down? Factorize this. Who can tell us? Now, we have something we call AC method that you can be using. AC method means, what is A? AC method means we need something that will multiply that will give us this. And we need the same thing that when we add it together, it will give us 6. So we know, you and I know that our AC in this case is 8. We are looking for. In 8, you can say 8 multiplied by 1. You have 8. But when you add it together, you have 9. Am I right?
Yes, sir.
But the same 8, we can break it down by saying
4 times 2.
4 multiplied by 2. You give us 8. But when we add it together, we have 6. You can see it's work here. Do you agree with me?
Yes,
It's
sir.
going to work for us here. So factorization, just open the two brackets like this. You know m is squared, m is there. Now, these two are positive. That is positive 4, positive 2. So that is what they ask you to do. Everything now equals to 0. Everything equals to 0. We continue from it. That's what we are doing. We are continuing it from here. So what is our m now? Our m in this case, you have m plus 4 equals to 0, or m plus 2 equals to 0. M equals to
minus 4.
Minus 4, or m
Minus
equals
2.
to
Minus 2.
Don't forget our real root. Our distinct real root then says what? Y is equals to C1 s raised to the power m1 plus C2 s raised to the power m2. So which is y equals to C1 s raised to the power minus 4 plus C2 s raised to the power minus 2. That is the solution we are asked to do. Any question?
Yeah.
Okay, let's continue. Number 2. What about situation? That's example on real roots. What about when you have homogeneous form? We call it repeated. Real roots. Repeated real roots, the formula is y equals to C1 SM plus C2 SM1 and SM2 ln X. That's the nature of that result. But let's look at the example there. Example is 9x squared y prime prime plus 3x y prime plus y equals to 0. So in this case, we go back to our formula that we declare up ax squared, or am squared rather, plus bam plus c equals to 0. What is a in this case? Anybody?
9.
A is equals to 9, and b
Plus 3. That's 3.
and c.
1.
Good. Can we please substitute? Everybody, can we solve it? Solve your m. Let me see what you get. We have 2 minutes to do that, or less than that. Just make sure you participate. Yes, anybody? So we have 9m squared minus
So
yes.
M will be minus 1 over 3.
M is minus 1 over 3.
Yeah.
Is that your answer?
Why?
M is 1 over 3.
M is 1 over 3. Is that your answer?
Yes, sir.
Okay, let's continue. I'll keep the two of you. Ibrahim, Kausara. Okay. Let's do it together. What is B? 3 minus A, 9, plus 1 equals to 0. So you have 9m squared. This is minus 6. Minus 6m plus 1 equals to 0. So in this case now, we have square. And how do we do it? M will first of all be inside, but M will not be only be inside. Remember, the other one we have 1 as a coefficient. That is why we use M alone. But in this case, we have 9, which is 3M and 3M. So in this case now, minus 1 minus 1. When you open this bracket, would I get the same thing back?
Yes, sir.
Please talk.
Sure.
Yes,
Are we
sir.
going to get 9m squared minus 6m plus 1?
Yes, sir. You get it, sir.
Okay, good. Now you agree. So we now have 3m minus 1 equals to 0, or 3m minus 1 is also equals to 0. So you have our m1 to be equals to 1, because this one will have moved to this side, positive, over 3. Any question? Or 3, our m2 will also be 1 all over 3. Therefore,
Repeated.
you agree with me now?
Yes, sir. It will be repeated.
Listen, anytime you are solving a quadratic equation, quadratic, always have it at the back of your mind, you must get 2 answers. You can't get 1. Because of plus or minus from the definition here. Look at it. It simply means you have to do the plus, you have to do the minus again. So take note of that. So you can see it's repeated. So all you need to do is just to plug in your y into here, your m into this place. So our y will be, therefore, y is equals to C1 s raised to power 1 over 3 plus C2 s raised to power 1 over 3 1 over 3 ln x. Because remember, we prove all these things from day 1. Go and check your notes. So ln x. So any question? So anytime you are working and you have your m or your quadratic equation that happen in a repeated form, let it be at the back of your mind that, oh, you are working with ln x. But what about the situation whereby we have homogeneous? Homogeneous form in a complex roots. So in this case, our y is equals to s raised to power alpha with C1 in bracket beta 1, sorry, beta ln x plus C2 beta ln x, C2 sine beta ln x. But in this case now, we have our y, our m equals to alpha plus or minus beta I. I means complex number, which implies that y is equals to exponential of x, C1 cos beta x plus C2 sine beta x. So we have this. But can we look at the example that can lead us into this complex analysis, complex roots? When you have x squared, y prime prime plus or minus 9x y prime plus 28y equals to 0. What is a in this case? Remember, am squared plus b minus am plus c equals to 0. What is a in this case?
1.
1. Our b is equal
Minus
to
9. Minus 9.
our c
28.
28 equals to what? Equals to 28, okay. So we can now go ahead and substitute. M is 1, a is 1, m squared plus what is b? Minus 9 minus 1. M plus 28 equals to 0. So I gather what? M squared minus 10m plus 28 equals to 0. So how do we solve this? Remember your m. What is our m now? Anybody? You cannot factorize this. You know that.
Yes.
Okay. Since I cannot
Yes.
factorize it, I can use minus b. I can say minus b plus or minus square root of b squared minus 4ac over 2a. Where your a is 1, a is equals to 1, b here is equals to minus 10, and c is equals to 28. Substitute it into your formula. What do you have? You can as well solve this one alone. B squared, what do we have? B squared minus 100, or let's do it step by step. Minus 4ac. We have it to be minus 10 squared minus 4 multiplied by a, 1 multiplied by c. So what is the answer now?
We're still working on it.
4 times 28, that's what you need now. 4 multiplied by 28, what do you have?
112.
1, 1.
112.
112.
Minus 12.
So what is 100 minus this?
Minus 12.
Minus 12.
Minus 12.
Minus 12, not ordinary 12.
No, it's minus 12.
Yes. So you have minus 12. So don't forget, I have here, what is my b? Minus into minus 10 plus or minus the square root of minus 12 divided by 2a divided by 2. That is what I have. That is my m that I'm looking for. But in this case now, I can open the bracket by saying, I can break minus 12. I can say 4 times 3.
Yes,
Do you agree
sir.
with me?
Yes, 4 times 3 is 12. Then we do square root
So we
of 4.
have 10 plus or minus 4 times 3 is what? Times negative 3
Yes.
divided by 2. 2 is, this one will give me 2, right?
Yes.
I can say 2 is common to all of them. Okay, let me just write 2 first. Let me just write 10 plus or minus 2 square root of 3i. Do you remember 3i? Divided by 2.
The complex.
Complex because of negative. I already take the 4 is out already. So I need to eliminate the 2 denominator. 2 is common up. I can say 2 in bracket 5 plus or minus square root of this divided by 2. This one will go with this.
So the I should be outside the bracket the moment you are removing the minus.
Which of the brackets?
3i, the I should be outside the square root, I mean.
Is the
No.
complex?
It's
Is
complex
5.
now.
Your m is plus or
the
minus
no
square
longer
root
there.
of 3i. Are you getting what I'm saying now?
All right, sir.
This is your m now. So if our m is this, look at the definition that I gave you here up. I said m is equals to alpha plus or minus beta I. And you know the beta, so we can substitute down. What is our alpha now? Our alpha is equals to what? I need
5.
someone.
5.
You said?
5.
5, correct. Then our alpha is 5. Then beta is what?
Root 3.
Let's say beta I.
Root 3.
Root 3i. So this is what they ask you to do. Now we can go ahead and substitute it in our definition for complex. The definition for complex is here. All you need to do is learn how to speak this language. Substitute it there. And that will be the best thing. Our beta is root 3. So let's substitute. We have our y to be equals to x raised to power 5 into C1 cos square root of 3 lead x plus C2 plus C2 sine root 3 ln x. Any question?
Sorry, where is the I? That should be 3i now.
You said?
Already. Where is the I? Did you throw away the I?
We remember that on a normal day, we are not, the definition does not contain the I. And besides, you can cancel I from beta. If I say beta I equals to 3 root 3i, I can say I cancel I. But in that case, you will not get I. You only have with beta alone. You agree with me?
Okay.
From here. So you don't even need to show us the bit the I, because from here you have already nullified each other. Then if you want to write it in exponential form, you can go ahead and do it this way, of which is not necessary for now. So any question? Who is Galaxy J6? Can you use your name? Just go to the participants and rename it. Beula, how are you? Who is Joshua? Are you there? Can you guys hear me?
Yes, we can hear you, sir.
Okay,
So we
let's
can
move
hear
on.
you.
So we need to check a point whereby you have okay, can we solve this one before we proceed? Everybody, I want you to participate in it. If you don't participate now, I hope you participate in the exam. So what is, use the method. We have 3 minutes to do that, 3 minutes. Once you're finished, just raise up your hand. Okay. Folashade.
Yes, sir.
Yes. What's the solution?
I got y equals C1x to the power of minus 6 plus
X raised to
C2
power minus 6.
plus C2x.
Okay. And let's keep your own for Lashadi. Yes. Any other person?
Yeah, I got the C1 f is power 1/3
X raised to power
1/3 plus C2 f is power minus 2.
Okay.
So I got the same answer as Ibrahim.
You got the same answer with Ibrahim, Kausara.
Mr. Ibrahim, sir.
Okay. Who again? How many of you with Mr. Ibrahim?
But my own C2 is now C2x is power 2, not minus 2.
There is not the same now. Minus, you don't know the meaning of minus and positive.
Sorry, sir.
Y equals to C raised to power 1, S raised to power 1/3 plus C2, S raised to power 2, right, Kausara?
Yes, sir.
So I've changed your own to the. We will see now. That's how you practice. Who again? Okay. Let's check the 3. I'm happy at least you guys, you have, you are doing something. So I can go and sleep now. My student can now solve the problem.
Don't go and sleep. Oh, you still have a toddler in the midst.
You still have what?
A toddler in this group. Still learning.
Okay, let's continue. Let's solve this one now. What is, we have the formula A. Not all the people, not all the material you see with this formula, but I think is the simplest one of solving it. It will help you to grow. Since we prove it together, you know the way we prove this one. So if I'm using it continuously, you will appreciate it better because you know the source. So this is the answer they got. Let's check them. What is A? Our A is what?
3.
A is equals to 3. B?
B is 8.
C?
Minus 2.
Let's substitute it. We have 3 m squared plus B is 8 minus 3 m minus 2 equals to 0. So we have 3m squared plus 5m minus 2 equals to 0. Now, at this point, don't deceive yourself. If you cannot factorize, use the general formula. Nobody will crucify you. General formula I'm saying is minus b plus or minus square root of b squared minus 4ac divided by 2a. Use it if you know you are comfortable with this. In this case, I can say my a is equals to what? 3, b equals to 5, c equals to minus 2. Substitute it here. Don't just rack your brain. I will have minus 5 plus or minus square root of b squared is 25 minus 4. What is a? C is positive, negative, right? It talks to positive. My a is what? 3. My c is 2, negative 2, divided by 6. So you have minus 5 plus or minus. Let's do this one. What do we have here? This is 24.
You have 24.
This is 49, right? Hello?
Yes, sir.
Yes, sir.
24 plus 25.
That's 49.
Square
49.
root of 49 is what?
7.
Divided by
Square root
6.
of-
So in this
49,
case
7.
now, our m is equals to minus 5 plus 7 divided by 6, or minus 5 minus 7 divided by 6. So what is m? This is 2 over 3 over 6, which is 1 over 3, or
Minus 12 over 6.
minus 12 over 6, which is minus 2.
Which is minus 2.
Our m1 is equals to 1 over 3, or an m2 equals to minus 2. What is your y? C1 s raised to the power 1 over 3 plus C2 s raised to the power minus 2. How many of us got this one?
I.
I did.
That's
said
why
what?
I was wondering that she got confused. The minus 2, she's actually is plus 2.
Don't
I'm
mind
wondering-
that. I was just like, I just tip your leg. You see, that's how you missed it. That's how people make mistakes. You have to be careful with the sign. See, follow the best method you know how to use very well. Nobody will crucify you.
That was my mistake, sir.
Aha.
I didn't take note of this.
That is the beauty of mathematics. Any route can lead to where you are going. For Lashade, well done. I can see where you made mistakes. Do you know the place?
I'm trying to look for it.
No, it's very simple. You see,
No, I use plus 6 and minus 1 was my when I was factorizing.
that is the issue. What do you use?
I use 6 plus 6 and minus 1.
No.
Right.
So you remember, this factorization is here. Let me do this one. You said you have 3r squared, or 3m squared, rather. 3m squared plus 5r minus 2 equals to 0. Right?
5m
equals to 0. So in this case, you have to be smart and be careful here, or else you missed it.
Okay.
One of the things, remember that you cannot split the 3.
Yeah.
Is it not 3 times 2 that we use?
No. In this case, you cannot use AC.
Okay.
Are you getting it? Because 3 is involved.
Okay.
But if I want to use AC, I can use AC. There are ways of solving it.
Oh, wow.
It's actually elementary. This thing was taught to us in GSS3.
But you will discover that for you, this thing can make you lose the mark, which happens to Shadeda.
Of course, it happens a lot. That's why people just use the formula method.
Just, you see, I always advise, if you know you cannot stay true, use general method. Now, in this case now, you agree with me if I said 3m, minus 1, r plus 2.
Plus 2 m.
Oh, wow.
If you open this bracket, are we going to get the same thing? Let's try it. 3m multiplied by m. 3m squared. 3m multiplied by 2.
3m. Okay, that's plus. Yeah.
That's
This
5.
one multiplied by
Okay,
this.
6m.
Yes.
M
This multiplied by this.
minus 2.
Minus 2.
Minus
The mistake Charlie make is here.
Okay.
Because you're supposed to remove 1 from it. This one is more or less as if you are using completing the square method.
Okay.
Equals to 0. You agree with me now? So this one would now be 3m squared plus
Plus 5m
5m minus 2
minus 2
equals to 0.
equal to 0.
Have I explained
My
it now?
suggestion is that
Yeah.
So-
Excuse, sir.
Yes?
Now,
my
where
suggestion,
we
okay.
brought out 3m minus 1 into m plus 2. How did we do that?
Okay. That's why I said is there are some things that are instinct.
Sir, because I know that once we are able to get that, we can easily get that our m equals to
I
1
agree
over.
with you. I agree. Let's look at it together. Number one, something is common to them. What is common? I know in two brackets, this is the way I used to do it here. I know m is common. M must be in all of them because m squared is there, right?
Yes.
Now, I would not think that, okay, how do I get 5m? Because, excuse me, I know that if I use AC method, let's look at AC method. If I said 3 multiplied by 2 will give me 6. Right? Now, if this one give me 6, already I know I have 6m in between. And I need 5m. So I can rewrite it by saying 3m squared plus 6m minus m minus 2. I will not touch these two at all. I only need AC to tell me what will I need to remove that will give me 5m. Do you agree with me?
Yes, sir.
Now, I know m is common. I can just do it this way. M is here. I will just look at the way I do. It's elementary, but it's real. Are you getting it now?
Yes.
So something is common here. What is it?
3m.
3m is common. Remain what?
M plus 2.
Plus what?
2.
Abby?
Yes.
So I need this place too to be in the same, something similar. Something is common here. What is common?
1.
Not 1.
Okay. Minus 1.
Minus 1. So I would now write, if minus 1 is common, I have minus.
M minus.
So now you agree with me. If I said 3m minus 1 is here, then I pick either of the two.
Yeah, that's simple. Very good. I don't know.
So anytime you know that AC cannot work directly, the way I did the first one, use this one. Make sure that your AC will be the one that you will know that will give you the clue how to deduct, how to make this one 5m. So all those people that use, they will just look at the question, they say, oh, let's use this. That is what they normally do.
So my suggestion is that it's better to use the
use your
method.
general formula.
The reason being that, like I was not even sure that it was factorizable. So I just went ahead to use. So
use your general formula. I agree with you.
If you try it and it's not factorizable, that you're wasting your time already.
You don't even bother yourself at all.
That's what I did.
I hope it's interesting.
Yes. No, you don't know. Yeah, I don't know. So I'm learning.
Yeah. So let's move on to second order So when we have, don't forget, this is just homogeneous. But when we don't have, when we have non-homogeneous, second order, we call it Cauchy. They are also mathematicians. Cauchy and Euler, they are both mathematicians. They discovered this method that we are using today, differential equation. So now, what are the things we need to know? Let's write the formula. How do we solve this one? This will take us to variation of parameters, where we use Roxian to solve the problem. You remember? So number one, let's write our equations out. Equals to g of x. G of x now, g of x is not equals to 0 here. Please take notes. Now, how do I solve it? Roman figure 1. Solve associated homogeneous equation. That is as squared y prime prime plus bs y prime plus cy equals to 0. So you first of all make it homogeneous to solve. Don't forget. Then number 2, you will now divide equation by as squared. That is the first term. Your first term that we are dealing with. Y prime prime by variation of parameters. So at this point, you now apply the Roxian that we did last time. How many of us still remember? If you've not watched the video, don't waste your time. Go and watch the video of how do we solve the Roxian method. They are there on your YouTube. They are also there on your portal. So it will help you when you watch those videos. It will give you a good foundation to some of those problems we are solving now, so that you will not be like, what are they doing now? Because everything we are doing now, to some people, we are just speaking grammar. If you are coming to this class for the first time now, you'll be like, oh, what kind of language are they people talking about? Are we still going to write the same course? Yes. The Roxian says, in this case, we use Roxian like I told you. W mean y prime, y1 and y2, then y prime 1, then y prime 2. So you get the w1, which is the same thing as 0, y2, then here g over as squared, then g2 prime. Then y2, omega 2 will be y1, 0, y prime prime and g of as squared. So we are going to make use of this. And in this case too, don't forget we are going to have general solution to be y equals to yc plus yp. Remember, you will have gotten your yc using your complementary here. When you solve your homogeneous, you get your yc. Then when you, for yp, our yp, which is y particular, is y1, is u1, y1 plus u2, y2. So let's look at the example. When we solve the problem, you will understand it far better. And be sure all your equation, your solution, they are linearly independent. So let's look at them. Example. You have x squared, y prime prime, minus 2x y prime, minus 4y equals to 1 all over x. Now, we know the method. The method is am squared plus, what is it? Can we say it, please?
B minus 1, B minus A, B minus
A
M plus C.
Plus C equals to 0. So in this case, we have A to be what?
1.
What is your B?
Minus 2.
Your C?
Minus 4.
Then your G.
1 over x.
Remember the formula here, the general term here. We can call this one equation star. So we move on. We can look for, substitute our value. What do we have? You have m squared plus minus 2 minus 1 m minus 4 equals to 0. So you have m squared minus 3m minus 4 equals to 0. So in this case, you have m minus 4, then m plus 1 equals to 0. So m is equals to 4, m is equals to negative 1. So what is our general complement? Our complement, the complementary solution says C1 s raised to power m1 plus C2 s raised to power m2. Remember, they are distinct, and our C, yc is equals to C1 s raised to power 4 plus C2 s raised to power minus 1. So now we have the C. So we can continue to solve for the second phase. We need to get our, we have a YC already. Remember that they said our first term, we divide it by, for us to solve this problem, the question is y squared, y prime prime, minus 2xy prime, minus 4y equals to g. Now, if it's equals to g, How do we get G? We have the G already. So what we need to do is, what is G over AS squared? What is AS squared? Anybody? What represents AS squared in the question we are given? This is our question.
Y prime.
You said?
Y prime.
No. It's more or less S squared. It's the same S squared. Y prime is just differential equation. Do you understand?
Yes, I get it, sir.
So now we have 1 all over X as your G divided by S squared. So at the end of the day, you have it to be, you can resolve this one. You have 1 all over S raised to the power 3, which is the same thing as S raised to the power minus 3. So we have it as S raised to the power minus 3. Just keep it somewhere. Don't forget your YC. We need to differentiate YC too. What is YC? Can we differentiate it? Anybody? Differentiate your YC. What do you have?
That would be 4C1 S raised to the power 3.
Just do it inside your notes, and then
Okay.
we will now look at it together. Anybody?
Yeah.
Now, let me explain to you. At this point, under the YC, what this thing means is very simple. If you look at it very well, our YC is like C1S4 plus C2 S raised to the power 1. So in this case, this entire value represents your Y1, and this entire value represents your Y2. Are we together now?
Yes,
Without
sir.
the C, without the C1, C2, C1, C2, they are just like, when you integrate both sides, you have to add those value to it, right? So now that I know what is my C1 and what is my, how do I differentiate this? Somebody have done that before. Tell me, what do you have here?
4C1
4C1
S raised to the power 3
S raised to the power 3.
minus
Okay.
C2 S raised to the power minus 2.
Good. So in this case now, that we have this, we have our Y1 to be equals to S raised to the power 4. Y2 is equals to S raised to the power minus 1. Then Y1 prime is equals to 4S raised to the power 3. Then Y prime 2 is equals to minus S raised to the power minus 2. Do you agree then? Hello?
Yes, that's it.
Do we all agree?
Yes, I will agree.
You don't have options, you just have to agree. I'm just kidding. Anyway, it's just like You know, in mathematics, the beauty of mathematics is this. There are certain things you will not get in class, except if you are deceiving yourself. And I always tell my students, please, don't say until you know one line, that is where you continue learning in class. No, just be learning along. Continue. Just write. Make sure you write. By the time you get to your own personal space and you begin to study it, you will grab it. Don't argue with them. Agree with what they are saying, so far it's mathematically correct. That's why I said differentiate. You do the differentiation, you know is the normal differentiation is correct. Then put it there. Do you get it? So let's continue. We have a few minutes to go. We have W. W formula for Roxian says Roskian. So says this is S. Y1, Y2, Y1 prime, Y2 prime. So let's solve it. Y1, what is our Y1?
X4.
S raised to power 4, right?
Yes, sir.
We are using determinant
S raised to power
theorem.
4.
Yes.
Sorry, you know it properly.
Oh, sorry.
You're writing S4. S4 power 4.
S raised to power 4. Then Y2?
S to power minus 1.
Y prime 1 for S3. Don't forget, here is cross multiplication. This multiplied by this, and this will follow this, minus it. So let's solve it. We have S raised to power 4, right?
Yes, sir.
Multiplied by minus S raised to power 2. Minus 4x raised to power 3 multiplied by s raised to power minus 1. We know from the knowledge of indices. Remember, the negative is out. Let's just put the negative out.
Look, okay. I will call your attention to that.
Okay. So it's the same thing as s raised to power minus 4 minus 2, right?
Yes, sir.
Don't forget the negative is outside. You said minus s raised to power 2. So the same thing applicable to here, 4 s raised to power 3 minus 1. So you have 4 s raised to power 2. So that is what we have here. So we can say that we have it to be minus s squared minus 4x raised to power what? 2. When you add it together, minus 5s squared. That is your W now. Now let's solve W1. W1 says 0 for the initial entry, then G of AS squared, Y2 prime. What do we have? 0. What is Y2? Check your notes. S raised to power minus 1. What is Y? G divided by AS squared.
That was a S power minus 2, yeah.
S raised to power minus 2.
Do you agree?
Yes.
This multiplied by this minus this. So we have 0 minus in brackets s raised to power minus 1 multiplied by s raised to power minus 3. So what do you have? Minus s raised to power minus 4. So the last one we need to solve, we need to do before you write your YP. We are still looking for YP, don't forget. So W2 is, what's the formula for W2? Y1, 0, Y1 prime, G over AS squared. Which is, what is Y1 now?
S raised to the power 4.
S raised to power 4.
0. Then when you differentiate it, you have S raised to power 4, S raised to power 3, S raised to power minus 3. So when you cross multiply, what do you have? You have S raised to power 4 minus 3, right? Minus 0. Because this one will multiply by 0, will be 0. So at the end of the day, you have S in this case. Then for us to get our U1 prime, remember you have our YP is the same thing as U1, Y1 plus U2, Y2. That is what we are doing. But you cannot get U1 except you feel, because this is differentiation, you have to get U1 prime. You have U1 prime already, but you are going to U. That means you have to integrate what you get in U1 prime. So equals to W1 over W. And U12 is the same thing as W2 over W. So let's look at U1 prime now. Our U1 prime is the same thing as, what is W1? Please check.
Minus S
Minus
to the power
5x squared.
W1 minus
W1.
S to the power minus S to the power minus 4.
1 over S raised to power 4. Right?
Yes, sir.
Divided by, what is W?
W is minus 5x squared.
Is it minus or 5s squared?
It's minus, sir.
Let's check who.
It's minus
Okay.
5x.
Yes, I
Then what is W1?
W1 is negative.
Negative.
To the power of
S to the power
minus.
minus 4.
Negative to the power of minus 1. So negative, negative. This one cancel this, right?
Yes, sir.
So we have it to be 1 all over 5 raised to power 6. Do you agree? Hello?
Yes, sir.
Yes, sir. Yes,
Do we
sir.
agree?
Yes,
Yes,
we
sir.
agree.
So this is U1 prime. We now want to have U1. So our U1 alone will be U1 prime integration with respect to the X. So it's going to be integral of 1 all over 5, 6 dx. So can we solve, what's the answer, please? Integration. Somebody should do that for us. 1 over 5 is out. Integrate 1 all over S6.
Can't see the screen properly.
That is your U1. We'll do the same thing to U2. For U2 now, we have it to be integral of U1 prime, U2 prime. which is the same thing as integral of, how do we solve the U2? We need to get U2 prime first. Your U2 prime is equals to what? What is W2? Check your notes.
X.
Divided by W.
Which is minus 5x squared.
So you have it to be minus 1 all over 5x. Do you agree with me?
Yes.
So
Yes, sir.
you can now solve this one by saying U2 is the same thing as integral of U1 prime, U2 prime, which implies integral of minus 1 all over 5 we have 1 all over x dx. So which is the same thing as minus 1 all over 5 what? Ln x. That is your U2. So we will go back to our equation and substitute. We now have yp to be equals to u1 y1 plus u2 y2. U1 is what? Minus 1 all over 25 s is to power minus 5 multiplied by u1, which is s raised to power 4 plus minus 1 all over 5 ln x multiplied by 1 all over x. So if you can resolve it, you agree with me that this one will go with this, remain 1x. So you have yp to be equals to negative 1 over 25. Just write them down first. Minus ln x over 5x. So that is our yp. Now our general solution will now be y equals to yc plus yp. So what is yc? We know our yc to be y1 and c1 s raised to power 4 plus c2 over x. Then our yp will be minus 1 all over 25x minus ln s over 5x. Any question?
The only question is that they didn't provide a solution. They created a problem.
They provide, that's why we are using their method.
Because at the end of the day, the whole thing look complicated.
You said what?
I said at the end of the day, the whole thing look complicated. Each of them provide a solution that will make life easier.
Don't worry,
They did
the
not provide a
higher you
solution.
go in life, the more interesting it will become when it comes in terms of mathematics. By the time you go further, you learn more when it comes in mathematics. So the more you go, the more you see, the more you go, the more you see, the more you go, the more you see. So it's bound to happen that way. Any question, please? But I'll give you a question to solve, and I'll give you a final answer. Is that okay by you?
Okay, sir.
Yes, sir.
So that you follow the same example. is just like x squared y prime prime minus 3xy prime plus 4y equals to s squared. Follow the same step. Get your m, get your yc. You know from your yc, you get your y1 and y2. Differentiate your y1, differentiate your y2. Get your g over as squared. Ready. Then substitute them into your Roxian determinant. Then get your final answer. You do it very well. I will write the final answer here. Your y will be make sure your step they are very neat. Send it to me on a WhatsApp. Just send it to me on my personal WhatsApp, not on your page WhatsApp. And let me see your name on top so that I will know. So this is what you will have. That should tell you where you will get your link. You get your link along when you have repeated you have a distinct they are repeated value is what you get when you do your quadratic equation. So it contains ln x.
Yeah.
You remember the one question we solved with ln x? You remember? When you have repeated real roots.
Yes, of course. I remember.
Yes. So you have repeated real roots. That's where the ln x comes in. It's not bad. It's not difficult for you to solve. I believe you can solve it.
So this ln square x, is that what it is?
Yes. That's my theorem. How will we not get that one?
That means ln multiplied by ln leads to ln square.
Okay.
That's the meaning.
Okay.
Oh my God. Yeah.
Thank you, sir.
I think the class is more interesting now that the exam is getting closer. Some of us were